Okay, now just a quick reminder. This is actually the last chapter with the stoichiometry stuff. I know we took a little break in between. But your first objective, and this is going to go with the multimole ratios that we did yesterday. Okay? So your first objective is to figure out what is the mole that is given. What are they giving you? And then also, what is the mole that you're looking for? Okay, and so we're going to use the ratios that we used yesterday for that. So everyone got the template, right? The whatever's given, that chemical, and this is where all that's set up from those weeks before and those chapters before. Boys, let's pay attention. Nathaniel and Isaac, let's pay attention. We need to do that beforehand, okay? All right. Now, remember that this is where your units and your chemicals all pay off. Because whatever unit and the chemical you have here in the given is going to go down here. Whatever you're looking for is what's going to go up here. All right? So let's take an example. So like here, they're giving you 9 moles of oxygen gas. Remember, anytime you have a gas, that means you have an O2, okay? And you're looking for KClO3. Now, I had, in the period before, there were a couple of things. Guys, remember that if you don't remember the names of the polyatomic ions, you still have that polyatomic ion sheet from before. So you need to go back and look at it. So there's a big difference between potassium chloride and potassium chlorate, okay? So if you need that handout, remember the old, not the polyatomic ion, but the old handout, the periodic table that folds, it has the names of those polyatomic ions, okay? All right, now, you're going to always give your given, and so since my given is 9 moles, let me, where's that not writing? We're going to put 9 moles of the O2. Your given always goes on that first spot, okay? So now, whatever this unit is, because we have the mole of O2, we want to cancel it. So that's why the mole of O2 is going to go down here, because we want to cancel that unit. The unit that you want, Nathaniel, let's pay attention, is what's going to go on top. So the mole of the potassium chlorate goes on top. This is the unit we want because we want our answer to be in moles of the KClO3. Okay, now don't forget, you're getting points for the number, for the unit, and for the chemical in every single spot, okay, of your railroad track. So now you're going to look at your equation. Remember that those coefficients is what's giving you the mole. That's what we did yesterday, remember? So the O2 here, we're going to get that coefficient from that O2. So what's my mole? What's my number? What's my coefficient for oxygen gas? Huh? What's your number that's in front of O2, guys? Yep, that's it. You're just going to get it from the equation. So it's 3. Now you're going to look for KClO3. What is your coefficient that's in front of KClO3, your potassium chlorate? Boys, let's stop interrupting during class. And so unless we're participating, we shouldn't be talking about other stuff. So what's your coefficient for KClO3? It's 2. And that's going to be your mole that goes there. So now all you're going to do is multiply and divide. On the top part is where you're going to multiply. So 9 times 2 is what? 18. Very good. 18 divided by the 3 is 6. Very good. So you have 6 moles of KClO3. That's it. That's all there is to it. Okay, Where do we have a question so far? Where do we have a question so far? Are we sure? Let's do another example. Let's pause this and put another. Okay, so let's, instead of 9, let's make this 15 moles of oxygen gas. Okay, and let's pay attention. All right, and instead of looking for KClO3, let's look for potassium chloride. Okay. So we're going to look for the mole of potassium chloride. All right, and we are given 15 moles of O2. So this is going to change to 15 moles. And instead of looking for that, we're going to look for the moles of potassium chloride. Okay. All right, so what's my first thing? What do I put first in that first box? In this first box, what do I put in there? Yep, and not just 15, it's going to be 15 mole of O2, okay? Because that unit, this mole of O2, because I have it there, that means I have to have the mole of O2 here. Yes? Okay, so now, what is it that we're looking for? What you're looking for goes on top. Yep, potassium what? You're looking for the mole of potassium chloride, right? So now this is where you look for this on the equation. So now, what's my mole for potassium chloride? What's my mole for potassium chloride? Remember, your coefficient is your mole. Yep, it's going to be a 2. So you have 2 moles of KCl. What is going to be my mole of oxygen gas? What's going to be your mole of oxygen gas? Yep, because that's your coefficient. You're going to put 3 moles of O2. This allows you to cancel out the moles of O2, and you're going to get your answer in mole of KCl, and I ran out of space. Okay, so you're going to multiply the top. 15 times 2 is how much? 30. Very good. And now you're going to divide by 3, so that's going to be how much? It's going to be 10. Very good. So you're going to have 10 moles of KCl. Okay, and that's it. The hardest part is looking for what is given and what is unknown. You need whatever this unit is, it must be down here so you can cancel it. And then whatever you're looking for is going to be on the top. Okay? That's going to tell you whether you're going to multiply or divide, what numbers you're going to put in there. Okay? All right, where do we have questions? Where do we have questions? Are we sure? Okay, all right, so now